Hey there guys and gals, it's me nirex and welcome back to the NSL creation series, Project NSL. So in this video we're going to begin creating our repository and our project. So first thing we need to do to create any project is create a repo in a Git host. So it doesn't matter what Git host you use, be it GitLab, GitHub, whatever the hell, just use Git, please, for the love of God, use Git, don't use any other version control ever. So we're going to go ahead and create our Git. Now I've already created it and removed it because I was recording a video and I didn't like that video, so we're going to do it again. Just go ahead and hit Control and N to create a new repository, anything you want it to be, and then we name that repository. Obviously it's going to be NSL, the rest is storage library. Library to create to save and load the state of your application in runtime. Oh, actually, application. It's obviously going to be happening in runtime, so shouldn't be any issue. Now I'm going to take this local path and save it. I'm going to initialize it with a repository, put gitignore into C++. Now, it's a bit messy, so we need to make some edits, make some changes to the gitignore file. Loss is going to be MIT, so everybody can use it with ease. And I'm going to go ahead and create a repository. Quite simple. Alright, so now I have the repository all created and good. I can go ahead and publish it, but I'm not going to do it just yet. And as you can see, I've already done it a couple of times. Okay, so let me just go ahead and open Visual Studio. We're going to go ahead and, where was it? Create a new project, easy peasy. Now, you could go ahead and use dynamic link library, but it's going to go ahead and automatically create some useless bullshit for you that you don't really need. So we're going to go ahead and go with Windows Desktop Wizard. I'm going to go ahead and copy the path there, name it NSL. Put in another folder in there called src, and then do NSL. Alright, so NSL is going to be created over there. Alright, create directory for solution. Do I need it or not? Well, it's just going to be one library, so, well, actually, yeah, because I need to be able to test it later, so, yeah, I need a solution. Or rather a directory for my solution. And I'm going to go ahead and click OK. Now it's going to ask me what I need. Definitely not an exe file, definitely not a static library, I need a dynamic library. Definitely going to be an empty project, no precompiled headers, and security lifecycle should be checked. Let's go ahead and hit OK. Now it's going to give me an absolutely empty project. Alright, nothing is in here. Now if I hit Control Shift and B, as you can see, one succeeded. Now, if I was going to create a rather normal library, or rather, not a library, a normal application, this would already fail because it has no entry point. But good thing with DLLs, they don't really need entry points. Okay, so the first thing I always do when I create a new project is make a new header files. Name it usually system defines. Something like that. All good, all dandy. Now, instead of doing what I always do, let me just go ahead and copy something from that guy. Don't worry, it's nothing too important. It's just this guy right here, right? I just need my... Yeah, there we go. So what I'm going to do is I'm going to go ahead and put my copyright notice up on the top. First thing we're going to do, let me just put that guy back there. Okay. So first thing we need to do is create a safeguard. Now I know pragma once is good, not bad, but we need to do if and def. And system defines h, define this guy, and if, like that, and all good and dandy. We have created our safeguard, all good. Alright, so this is something kind of DLL specific. Now, I can show you, or rather, you can go Google and see exactly how you figure this out. It's already there in Microsoft, MSDN, Microsoft documentation, if you are interested in knowing how you can make a DLL file. But we're not, because I already know it, so we're just going to do it. So I'm going to make another safeguard. Say define an export h, or rather, there's no h, if an export we're gonna define actually an API as decal spec. Decal spec. There we go. Decal spec of DLL export. Alright, so if export is there, or rather if defined like that, we're gonna go else define an API as decal spec. Come on, I always hate this guy. DLL import. Alright, so if we're not exporting, we're probably importing, and we do end if. Alright, which if are we ending? We're ending this guy right here, and actually this is the guy right here, so we're gonna go ahead and do that. So if an export is defined right here, which it is, this is going to be our decal spec for our functions and classes. You know, DLL export, this guy is going to be equal to an API. Else, this guy is going to be equal to an API. Alright, so this guy can either be defined or undefined. If it's not, this guy is going to happen. If it is, this guy is going to happen. Alright, easy peasy, lemon, goddamn squeezy. That's the first thing I always do. Alright, so quite easy, quite simple. Nothing to be worried about, just some macro bullshit that we need to take care of all the goddamn time. Now I'm going to go ahead and define some other things. Let's say we need... What do we need? We need an API. Well, actually, we don't need an API. We need an NSL, just like that. And we need a version, or rather a version, like that, which is equal to 0.1b. Actually, let me just take that b. 0.01, or something like that. It doesn't really matter. Let me just put that 1 there. So, you see, I'm not prepared. I just don't know what the hell I'm doing. So, yeah. And that's basically it for this guy. Now let's go ahead and create some of the utility classes that we're going to use. So first utility class, well, we need a filter first. So we're going to go system. System defines is going to be under system. We're also going to go ahead and do, well, what do we need? So we need to be able to save and load everything. Alright, so obviously we need another filter called interfaces, because we need interfaces for this to work. We need to be able to import and export every kind of class. Whatever class you make, you should be able to import and export it. It should be extendable as hell. So we definitely need inheritance and interfaces. Definitely. It's just a must. So I'm going to go ahead and create a class, name it IStorable. And the reason why I'm naming it I is because it's an interface. You know, that's why it has an I. So IStorable, anything that can be storable, it's going to be there. Also, why did I put that there? Interfaces don't really need source files. They're just header files. So it's going to go in there, IStorable. It's going to be a class, obviously. It's... Alright, let me just go ahead and do something like this. There we go. And we're going to do something like IStorable. If that's the case, then we don't want that. Alright, so IStorable is going to be there. We're going to go ahead and include system defs because I need that an API thing. There we go. So this class is now being exported to DLL. Kind of useless because it's only a header file. Nothing to be worried about. Now this guy has 2 functions. Alright, so obviously we need something to be able to do what we do with. So we need a string. We need string to be in here because we need to use that string. Alright. Now, IStorable can only have 2 numbers. Or rather, two functions. 2 member functions. First one is going to be load function. And the second one is going to be save function. Alright. That's the only thing that we need. Or let me rename store function and retrieve function. And did I write it correctly? I don't know. Not sure. Let me just double check. Yep, all good. So we're going to have store and retrieve. Alright, so what the hell is going to be stored? Whenever we store something, we need to return a bool. Alright, so virtual bool, because it's going to be an interface, but that's why it's virtual. Virtual bool store. and it's gonna take nothing, and that's it. All good. Now retrieve is gonna do virtual bool again, retrieve, and it's gonna take a stitch string. Well, actually, I'm thinking. No, actually, no. That's all good. So retrieve. Does it need to do that? No, actually it doesn't. So yeah, there we go. Well, does it or does it not? I'm thinking. Yeah, let's go with it does just for now. So we're gonna go in str. The reason why it's const because I don't want to change it. The reason why I don't want to change it because it's a reference type. The reason why it's a reference type because I don't want the string to be copied. And the reason why I don't want my string to be copied is because it's faster this way. So we're gonna be able to retrieve the data and we're gonna give it back out, or do we? Alright, so let's say I have a class. I want to be able to store that class's data, right? So I call store, some operation happens and it stores that data. Alright, so we need okay, alright. So let me just go ahead and go here and create two more defines. I'm gonna create let's actually put this. Nah, that's good enough. So we're gonna go ahead and define out and define in, define opt-in. Alright, and then define opt-out. So yeah. Define pure. Like that. Or like that. So this guy, instead of just being an out string or an in string, when we store something, when we save it, it gives us some sort of string, right? So it gives us some string, so out string, and then it gives us a bool to see if the operation was actually successful or not. This guy will actually give us out another. Well, wait a minute. So when I want to save it, well, I want to write it into a file. It gives me something to be able to write into file. This is going to be an in. Alright, so out, in, all good. And these are all going to be pure. And there we go. So basically what pure means is that it's equal to 0, so you can just replace it like this. You know, all works good and dandy. But I'm just going to write it pure because I want to. So these guys are going to be pure virtual functions, so this guy is an actual legitimate interface. So yeah, that's basically it, and we're not going to make it final. We're not going to, because it's an interface, obviously, duh. Let me just make a documentation for duck string for, bro, come on, what the hell. So I need a duck class for duck creator to, you know, later be able to generate my documentation based on this guy. So what I'm going to do is main interface for our storable, for all the classes that need the support, need main interface for all the classes that need to support saving and loading. Alright, or rather that need to have saving and loading functionality. Alright, so that's basically it. Now we have two more functions to take care of. Let me just go ahead and wait, like that. Let me just go ahead and see it here. Does this have documentations? I don't think so. No, this doesn't have autodoc, so never mind. Warp has, but we're not gonna go there. So I'm just gonna check it later. For now, I'm just gonna keep it. Actually, what the hell? Let me just check it right now. So nirex 0, nope. Dude, come on. Duck creator, yeah, there we go. So it should be good. Let me just double check my work, and holy hell, yeah, it's goddamn slow, Jesus. Alright, yeah, duck class, yeah, all good. So members are duck member, functions are duck func. Yeah, let me just go ahead and copy that. Alright, because I'm putting it here, it's all okay, all good. I'm just gonna do some quick shit. Alright, so we store the data within the class and return a, well, that's it. Store the data within the class in a string. And it has a str, or rather out str. It's gonna return the first, well, put the calculated string inside the str argument. Alright. We don't have a b, that's basically it. We also have a return. Returns whether or not the operation was successful. And that's basically it. Let me just take these guys off. Put that guy right there as well. So some of the things are the same. Retrieves the data from the given string and parses it. Well, actually, loads it into the class. Alright, so everything is good and dandy. Now we have an in string. Put the calculated string. Put the string inside the class's members. Wait, do we do it like this, or yeah, or rather objects. Members. All good and dandy. Returns whether or not the operation was successful. Now, here is something I want to do. Inside system, I'm going to go ahead and create another guy called nwin.h. And let me just go ahead and go back here. Where was this guy? Where was this guy? Come on, dude. And Windows, all good. So, well, yeah, I'm just going to copy all of this because, dude, no one can memorize this, believe me. So what's going to happen here is that I'm defining, you know, some bullshit. Alright, some bullshit right here. These are real, that doesn't matter. If you don't want Windows, you could just use these guys right here. If defined, we undefine it. If not defined, you know, just whatever. So we just safe check some of the things that might have been defined if you don't want to use Windows, but I actually do want to use Windows. So we're going to use Windows, but we're going to use Windows lean and mean because we're not going to use extra bullshit. We also are going to disable all of these things that Windows automatically brings in for us. So yeah, definitely not my thing. We're going to go ahead and include nwin. Alright, so whenever you want to inherit from this class, you automatically include nwin because. Now, it's not going to return a bool, it's going to return an h result. Like that. Okay. Well, let me just do something real quick. So I could just peek definition and return type success. Peek definition. Yeah, I could probably just do that. Now let's not bring an nwin here because we might not want to use nwin everywhere. So long, well, I could, yeah. So type def long h result. Actually, we're going to do it right here. Wait, what the hell? What am I doing? What the hell am I doing wrong? Yeah, that's... Ah, sure. Bro, come on. It's all good. So, we have that, and... So, if I take this away now... All should be good. So, they're basically the same thing, alright? So it's basically just a simple long, alright, just a simple long that holds some value in it. And the reason why it's a long, because we need some bytes to be able to store some value in this. So we're going to do that. yeah, and that's just it. So we created our first interface. We created all the good stuff. We want to be able to export this guy, so we put an API here, but it's not really needed. You could just easily take this out and there will be absolutely no issues. The reason to that is this guy is obviously, all of it is in .h. It doesn't even have a CPP because everything is pure. So yeah, that's basically it. And this video has already gone for 20 minutes and we already did nothing. So yeah, we accomplished so little. Doesn't matter. We're gonna do better next video, I'm pretty sure. Just the beginning of the project, you know, just to create the foundation is harder than actually going forward and doing all we do. Anyhow, that's been it for this video. I hope you guys enjoyed. If you did, leave a like, maybe leave a comment, maybe even subscribe if you really enjoyed. And yeah, make sure you ask any questions you have in the comment section below. And that's it for this video, guys. Thank you for watching and see you in the next one.